Good morning, everybody. I'm Mason Clay. I'm a civil engineer, and I'm here to present on reinforcement. We'll be looking at what exactly is reinforcement, how do we use it, the different types of reinforcement, common errors that are made or errors that are generally made on site, and some of the best practices that we can all adopt so that we have a much safer, stronger, more efficient building for anybody, whether it's residential, commercial, public structures, what have you. But we must always keep in mind that the safety of persons is very important. And we are very fortunate or lucky in that we in the Caribbean, if a structure fails, there's nobody to take us to court, or most times it's just a waste of time for us to go through the legal system to get any kind of reparation for, or to get any course of action for any structure that fails. If we were in a much larger country, the States, the UK, the Middle East, then it's very easy for you to end up in jail simply because a structure fails and you have hundreds of persons who may have died or gotten injured because of a failing structure. So reinforcement, So reinforcement is basically a material that we add to another so that we have something like, we combine it with another material so that we're improving the strength of that material. So reinforced concrete, for example, which is very typical, very easy for us to understand in this industry, is that we add reinforcement or steel to our concrete to help improve the tensile stress or the tensile resistance rather of the concrete, since concrete is weak in tension. So if we were to pull on the concrete, for example, then that concrete is going to start breaking away. That's why we add the reinforcement or we add the steel to it to help improve the strength of the concrete. Some examples that we have would be the rebars, which we generally use. We have the welded wire mesh, which we generally refer to as BRC, but believe it or not, BRC is actually a brand name. So the material is actually welded wire mesh. We also have different fibers like steel fibers, carbon fibers, polypropylene, if I'm correct. Yes, polypropylene fibers that we can also use. So each type of reinforcement has a different use. So the rebars we generally use for structural purposes. The welded wire mesh is also a structural purpose, but then we generally tend to use it in slabs that are on grade, slabs that are directly on the ground. The rebars we would tend to use for our suspended slabs, our beams, our columns, our foundations, all of those elements. The fibers, we also use it in, we can use it in any one of them, but then the fibers now are generally going to be used to reduce cracking or to control cracking. Just like the BRC, we put it at the top of the slab for us to be able to control cracking in the slab. We do not want our slab cracking, even if it is directly on the ground. We don't want moisture getting into that concrete because the moisture can, especially if we were in a temperate country, unfortunately for us, we aren't, that water can get into your concrete. At colder temperatures, that water is going to expand and cause the concrete to crack, which means that your concrete is going to fail. For the fibers are also used to control cracking, but then they're also used to help reduce bleeding. It helps to make the concrete impermeable. So then you don't have, and one of the things that we need or that's important for concrete is that we must retain that moisture within the concrete. That is the way that the concrete, something that we call heat of hydration, something that the concrete needs for it to be able to cure properly, so that we have a nice, strong concrete that's going to help distribute or transmit all of the loads that we are going to be carrying, because some of us might want a fabulous design where we have a roof garden or we have a swimming pool on the roof, and we need that structure to be able to survive. It has to be able to transmit those loads safely and efficiently to the bearing ground. I remember years ago, there was an incident in Guyana, if I recall correctly. Somebody had a massive roof garden, and then at some point in time, that building failed. Everything collapsed. What exactly the reason was, I'm not sure if they were able to determine it, But one of the first things that comes to my mind as an engineer is that that building was not properly designed to carry all of that additional load. So those are things that we need to keep in mind. So common errors. Although the first one I haven't exactly or necessarily seen it here in St. Lucia, where the welded wire mesh is placed at the bottom of the slab. But then I don't put it beyond anybody for that to happen, because we can have a young contractor who's now starting off, doesn't exactly know the ropes. Sometimes we may have contractors in the business for longer. I have been on this earth, and they may be making errors, not to insult anybody, but it's just the fact that some of them may be making errors that they themselves are not aware of. And there are in some instances, you have contractors who try to cut corners, who for the life of me, I don't understand why, because when we engineers come on site, we still have to inspect the reinforcement before you even pour concrete, which means it's going to cost you more. So when you take the shortcuts, you put less steel than you're supposed to, you space your reinforcement further apart than you're supposed to. When we come on site and we inspect the work before you pour concrete, we are going to ask you to adjust it, which means that in some instances where the reinforcement is too short, you now have to go and get additional reinforcement to replace it. So that's an extra cost to you. So those are some of the things, whilst we are cutting corners, those are some of the things that we need to keep in mind. Inadequate cover to the reinforcement. Now, in some instances, I have seen where steel cages are placed, whether it's for the strip footing or the pad footing or with the columns, the beams, whichever ones, that whatever blocks that you are using, the spaces that you are using, for you to get that cover that is requested or required, sometimes it's not even enough. There are times when the reinforcement actually shifts in the formwork itself. And when you look, you see to one side, if, for example, they specify that you need 2 inches on either side, the reinforcement shifts, and then you see on one side you have 3 inches, on the other side you have 1 inch. And then nobody goes back to correct it. Now, when that happens, that means you're making your reinforcement vulnerable, because you have things like driving rain. When the wind is blowing, it's going to be pushing or forcing that rainwater into the pores of the concrete. Because yes, we can design the concrete for it to be fairly dense and make it fairly impermeable, but the fact remains that we still have pores where that water can get into the concrete. We have capillary reaction, which means that each water molecule is linked to the other. So it's like a train, essentially. When one gets inside there, the rest are just following it. And then it gets in contact with your reinforcement, which will cause it to corrode. Now, when that happens, your reinforcement starts to expand. As it swells, it starts pushing out on your concrete ends up cracking. So those are things that we want to try to avoid. Insufficient lap splices. We as the engineer would specify certain lap splices. Now those splices are dependent on the diameter of the reinforcement. Now the general rule according to the code is 40 times the diameter of the bar. There are instances on other codes that may specify differently, like the US code, there's something like 48 times the diameter of the bar. So we as the engineer would check to see which one is most appropriate depending on the structure that we are designing. But then now when we specify the lap splice, say for example, we say that you need a lap splice of 2 feet, that's 600 millimeters. And then we come on site and the contractor has 400 millimeters. It is insufficient. There's a reason why we specify those lap splices. We need whatever stresses that build up within the concrete to be able to transmit properly to the supporting members and the supporting members down to the other supporting members. So for example, we're going from the slab to the beams, beams to the columns, columns to your foundation, foundation to the bearing ground. So those lap splices are given for a reason. So when you put less than what we actually specify, it means that you don't have enough length for those stresses to actually transmit fully and completely to the other members. So then now you have those stresses building up inside there, which is also going to cause those members to fail. So then when you come now and you put less than what we actually specify, we are going to ask you to change it. And then you hear some contractors, sorry, unfortunately, some of you might be grumbling and quarreling and complaining, but that's just the fact of the matter. We will ask you to change it, which means that comes at an additional cost to you. Positioning your reinforcement, especially when we have those lap splices. So whenever we have to splice the reinforcement, it means that we need a length that is much longer than the actual length of steel. So the length of steel is generally, I think, 19 feet, if I recall correctly. Some instances, some people will tell me it's 20 feet, but I know it's 19 feet. Yeah? They make them 20 now. So I'm kind of like from the old school chapter where it was 19 feet. So we may have a slab, for example, that measures 30 feet long. There's no way we can stretch a 19-foot or 20-foot bar to make the full 30 feet. Hence the reason why we splice them to increase the length of the bar. So whenever we have those splices, we need to make sure we stagger them or alternate the position of those splices. Because if we don't do that, then we end up with a zone that is going to be compromised. It's essentially a weak zone that you are creating within those members. That is why we tend to alternate or stagger the splices. The same thing comes to the stirrups, although I mentioned it later down in the presentation. But then when we have the stirrups for the columns and the beams, we also alternate the position of the hooks. We do not put all of the hooks in the same line going up, or whether if it's a beam in the same line going across. We need to alternate the position of the hooks. So if I start in the far left corner, the next one following will be in the right, then we go to the bottom, we go to the next one, and we keep going so that we do not create that zone or that line of weakness within our members. Yes? Well, by right, when we buy the prefabricated cages, and Bryce should know, because they should be following codes and regulations, that those should be alternated. So again, then we are left to rely on the quality of the weld to keep those hooks in place. And efficiency as well. So that's why they would do it that way. So that's why I'm saying then we would now then have to kind of rely on the quality of weld that they would use to fabricate those cages for us. Yes, but at a time that again would probably save you in the long run. Because if I were to come on site and inspect it, then I would ask you to change it. So you might as well just get it right from the get-go. Again, if we're in larger countries, then it means that somebody coming and inspect it, they will have you remove it. Because if that member fails, the building fails, and then that's a lawsuit or a mass lawsuit on your head. So that's all of those things that we want to try to avoid. Can I take the rest of the questions at the end of the presentation? So please don't forget your questions. Placement of reinforcement or insufficient hook lengths. The hooks are what we use generally to anchor, something that we call the anchorage length. So what it essentially does is that it reduces or it makes it difficult for the member for the reinforcement to slip out of another. So if we have a column and a beam, we generally tend to have the reinforcement hooking so that it increases or it makes it more difficult. If we have an earthquake, for example, it makes it more difficult from the beam to separate from the column. Whereas if you were to just place it straight, we have a sizable earthquake, then it's a lot easier for that beam to separate from the column. So we must have the hook lengths, which are generally 12 times the diameter of the bar. Again, all of those are written in the codes. So sometimes when the contractors want to cut corners, it may not happen immediately. It may happen in the next 2 days. It may happen in the next 6 months. It could be 20 years down the line, but the structure will be affected one way or another, especially if you have a sizable earthquake, if the loading that is carrying is way more, or rather, if you put less than what is required for it to carry the loading that it needs to carry. Like there was a building that I went to see personally that I was interested in, partially built reinforced concrete structure, 2 stories. And when I went to inspect it, I went to see, and you can imagine if I wasn't educated in the field, I would have probably just gone with it and say, hey, here's your money, give me the building. But then you have reinforcement, the main bars sticking out of some of the columns. You have reinforcement protruding so that they can later on come and build the stairs. And I'm seeing all T10s. When it comes to structural members, there's a minimum bar diameter that the code says that we need, which is basically a T12 or a 1/2-inch bar, high tensile bars. So those are things that we need to be aware of. If it's somebody who's not trained like the rest of us, they will gladly accept it. Or if they don't have somebody to guide them, they will gladly accept it. So the first thing that comes to my mind as an engineer is that that building needs to be retrofitted. Because there's no way that I am going to be using a building and I'm seeing my structural members have T10s in them. On top of which, the slab, the first floor slab was exposed, which means that it was exposed to water, all the elements. And you can see when you go on the ground floor, all of the water that was coming through the slab, which means that the steel inside of the slab has been compromised. So that in itself is going to cost tremendously just to retrofit it. A lot of things that we need to keep in mind. Insufficient reinforcement in foundation walls. When we have any walls or any foundation, anything that's going to be below ground, it means that we must have the reinforcement, especially if it's a foundation wall, in every other core or every block core. And we fill all of those cores with concrete. Because not only do we have the weight of the structure coming down, you have the soil pushing on the walls, you have the water inside of the soil that's also pushing on those walls. So we must put adequate reinforcement inside of those members. So best practices. For our walls, we need to position the reinforcement properly and correctly. Make sure if it is a foundation wall that we have our reinforcement in each block core. Again, the minimum diameter is going to be 12 millimeters or a 1/2-inch bar. That's just minimum for structural members. If it's non-structural, something like a balcony, a railing, something like that, we can use much smaller. But once it's a structural member, it must be a T12. It cannot be less than that. It cannot be less than that. Anything above ground, we can start placing it at every 400, every 600, which would be like every other block core, every 3rd block core. But those cores with the reinforcement must also be filled with concrete. The horizontal reinforcement in our walls, we must have at least 1 T10. I know the contractors prefer to use brick force because it is flatter, it is less cumbersome trying to place it between your rows of blocks. However, the brick force does not provide us with an adequate area of reinforcement to help distribute the shearing stresses, something else that we call shearing stresses. And shearing is basically a cutting action of an element. If it has too much load, then it's just going to cut. But the brick force does not provide us with adequate area to help transmit those stresses that are going to build up within the wall. Hence the reason why we tend to specify a minimum of T10 bars, even if it is more cumbersome for you when you're building the walls. If it is a reinforced concrete wall, then the structural engineer will specify, they provide the drawings for you. The lap splices and hook lengths depend on the diameter of the bar again. Your starter bars. Always have your starter bars when you're coming from the foundation going up, especially from the strip footing, so that we can properly tie the walls to each other element. So we're going from the foundation wall up through the slab. That starter bar has to go up through the slab. And from the top face of the slab, we need at least 600 millimeters so that we can properly tie the walls above the slab to the rest of your structure. Your entire structure must be tied to each other. All of the members must be tied to each other so that the loads and the stresses are properly transmitted to the bearing ground. This is an example of a wall with, well, I know this one shows the brick force at every other core, but as I said, we would prefer the T10 bars. And you have your vertical reinforcement in every third core. Example of a damaged wall where we did not have reinforcement. So yes, while you might have your running bond, which helps to tie the wall itself together, but we also need that reinforcement to help keep everything together so that that load is transmitted, especially if it is a load-bearing wall. Example of our starter bar going from the foundation all the way up through our slab and your minimum projection so that you can tie your wall reinforcement to it. And then the ways in which we need to tie walls that meet. So your walls can meet at a corner, you can have a T-junction, or you can have an X. That's a T-junction. And then where we have our X. This is an example of an end wall. So there are cases where you might have a wall and you have nothing else meeting it. But we need to make sure that we tie it properly. So that's an example of how we would tie the end of the wall properly. For your floors, if it is a slab on grade, you need to make sure that your welded wire mesh is placed at the top of the slab. If it is a suspended slab, then we have one mat, or one mat is required, is placed at the bottom of the slab. If it is two mats, then we have one at the bottom and one at the top of the slab. And again, the distance or the position of those depend on the cover to the reinforcement. You have the minimum diameter, which is specified. Again, as I said, it's a T12. And where we have splices, we alternate or we stagger them. For a slab on grade, where we have walls, we have a thickening, as you can see, under the slab. And we have that additional reinforcement so that we can transmit those stresses or loads properly and efficiently and safely to the bearing ground. And we have the BRC at the top. You have your starter bars projecting from the slab, or rather from the thickening, going up so that we can properly tie the reinforcement for the remaining height of those walls. An example of our slab again. And we have the cutoff bars at the top. Sometimes you might have a full mat at the top, but it's more economical if we just place the mat over the support at the top of the slab. This is an example of our reinforcement in plan. Practical example, slab on grade. For the columns, beams, and linters. Your linters are basically a small beam that we place over our openings. So we use a minimum for our columns, and our beams use a minimum number of 4 bars, 4 T12 bars. If your column is square or rectangular. If it is a round or circular column, we need a minimum of 6. Again, we stagger. If we have to increase the length of the bar, essentially for the beam or the column, we need to put our splices, but we also need to stagger them or alternate them. The hooks and stirrups, I mentioned that earlier, where we alternate them. For the stirrups, we use a minimum diameter mild steel, 8 millimeters. That's for residential structures. When we start to look at commercial structures, public structures, where you have hundreds of persons using those structures every day, then the stirrups that we generally recommend would be a T10 minimum for those stirrups. For the splices and laps, you'll have heard me say so probably a million times within the last 10 minutes. Your cover tier reinforcement, if it is in the ground, generally your minimum cover tier reinforcement is 75 millimeters or 3 inches. Now there are times when we can get away 50 millimeters or 2 inches, but then that means that your concrete must be outside of your water table. So if your water table is here, for example, then and our concrete or foundation falls above the water table, then we can get away with 50 millimeters. Although I personally would prefer to stick with my 3 inches or my 75 millimeters. But then if that concrete now falls within the water table where it's constantly exposed to moisture, we must use a 75 millimeters. It cannot be less than that. Again, we don't want that concrete penetrating the concrete and compromising our reinforcement. If it is concrete on the inside, then we can get away with the 25 millimeters once it's on the inside. Any concrete that is exposed to the elements mean that it's not in the ground and it's not inside. So anything that's exposed to the elements, the wind, the rain, the sun, and especially if we are within close proximity to the sea where we get sea blast, that salt in the water can also compromise the reinforcement alongside the water. So we generally use a minimum of 40 millimeters, although for constructability's sake, we tend to use 50 because 25 millimeters is equivalent to 1 inch. So it's a lot easier when we work with multiples of 25 instead of anything more or less or in between. Okay, so those are just showing your connections, the beam to the slab. We extend the stirrup into the slab, how we hook the beam into the column. And this one is basically showing the same thing, how we hook the beams into the columns. If it's an intermediate column or if it's an end column, we have our footing. So earlier on we saw for a strip footing, this one is a pad footing, where we have the mat for the pad, we have our starter bars, where you will have a minimum hook so that you can tie it to the mat for the footing. And your starter bars, again, a minimum of 600 millimeters. So that we can now tie the main reinforcement for the column cage onto that. Here's my presentation. Thank you very much.
Don't go too far. We may have some questions for you to answer. So, yeah, I think she said yes. One of our in-house attendees would like to ask a question. What?
There's nobody watching. Like we mentioned going 2 sides. Okay? But generally, nobody come to watch what I do. So I could just make shortcuts for you know.
Yeah, so okay, so for the persons online, he was basically saying that you shouldn't really call it common errors just because I think he was making the point that no one really supervises or oversees the project. And I think that ties in to an even more important topic that that a colleague had told me to make sure I mention, that many projects in St. Lucia don't have supervision of the contractor, especially the smaller projects. On the larger projects, government projects, etc., you would have the design engineer or project engineer supervising. I had made the point a couple of weeks back at a symposium that supervision of your contractor is important. I don't care if it's your cousin or your brother or whoever that's building for you. All right, I don't care what good price they gave you. You must have someone overseeing your contractor. You can't have someone supervising themselves. I don't care how good they are. They may make mistakes. You need to have someone who will come through before they pour a slab, make sure that everything is in place. All right. A lot of the time, clients will engage a contractor, but they have, well, a lot of the time they don't even have a proper contract with him, and they don't have anyone who is then between them and the contractor. So they listen to anything the contractor advises them on. But you need someone who is going to be reviewing the drawings, coming on site, making sure that his guys are actually putting the steel in the walls, making sure that you have those hooks that may showed going down into the beams. I mean, you don't even see those hooks on most sites down here. The guys will make the beam, they shove it into the cage of the column, and they tie it with some tying wire, and that's it. You know, but you need someone who will come through and make sure that all of these things are in place. Another thing that I don't see very often anymore is, do contractors down here still make the spacers? You know, you used to cast your little, the spacer blocks. I don't really see them anymore. Okay. So they're sold on a larger scale. But yeah, a lot of guys will just will pick up stones on site, or just break some blocks and take a piece of the block and put it below the steel for you and that sort of thing. Number one, it's not the correct height, because if you specify a 2-inch height, that's not going to give you the coverage you need. Number two, it's not tied to the steel. So if someone is walking on the cage or on the steel, it's going to move, and then you have it shifting to the edge. And as we mentioned, sometimes you get 3 inches on one side and 1 on the other, or ½ inch. You know, so these are the reasons, or sometimes it's touching the form. You know, so these are the reasons you need supervision. You need someone overseeing your contractor. You need someone, and it's not saying anything about the contractor. As I say, even the best contractors need someone who will oversee the project, you know, and ensure quality of work. So I think it's still errors that are being made, but you definitely need someone to come through and point out the errors and make sure that things are done properly. Are there any other questions from in-house? Marlon? So the question is, would she recommend plastic rebar spacers? Me? Remember, we have online.
My apologies. No, I would not exactly recommend plastic rebar spacers. I mean, I would prefer to use the concrete, because you have concrete, and especially if the edges are roughed up, then you can have a nice joint forming between the concrete spacer and the concrete that you're going to be pouring in the form itself. But with the plastic, it's not that easy for the concrete to adhere to the plastic. And depending on the type or the quality of plastic, it can deteriorate over time and leave that void within your concrete member. And the voids are what those large voids, unless they are actually designed for, are not what we want or looking for within any of our concrete or structural members especially. And
I'll add to that as well, that a lot of the plastic spacers I've seen can't take a lot of weight. So when you have a heavy cage and you have persons walking on it as well, they tend to bend a little bit, they compress. So they reduce on the coverage that you should have. We had another question? On what? Stirrup spacing. So his question is, can she speak on stirrup spacing? Yeah, that's true, you didn't mention.
With the stirrup spacing, again, it is specified. As engineers, we calculate how far apart those stirrups have to go. So then we cannot put them further apart. That is very true. There was something that I had to point out about the stirrups. Because then what happens is that what I have come across on site is that a lot of contractors, they tend to put the stirrups further apart than they need to be. And there's a maximum spacing that we would have to use. And we generally try to stay within those limits, so that at least we have some kind of wiggle room. At least if something goes wrong, then you have that wiggle room to fall back on. So if, for example, we design something and it says that we need to put the stirrups 300 millimeters apart, we might specify that we put it 250 or 200 millimeters apart. So with the stirrups, the closer they are together, the better. But then the further apart they are, the worse it's going to be, because the stirrups is something that we use to help distribute or transmit rather any sharing stresses that are going to develop within those members. And we tend to put them closer together when we get closer to the supports, because that is where your shear force or cutting force technically is going to be highest. So then that beam, for example, if you have a beam connected to 2 columns, then that force is going to be highest closer to the face of the columns. That is why, and is likely to cut right along the face of the columns. So that is why closer to our supports is where we put our stirrups closer together. And then as we go towards the center of the beam, for example, then we can put them further apart. However, again, there's a maximum distance at which we can put those stirrups. Same thing for your slab reinforcement. If it is a suspended slab, there is a maximum spacing at which we can put those rebars. Because again, the further apart they are, the harder it's going to be for those members to actually transmit the loads that they are carrying. So we want to keep it within a certain limit according to code so that we can safely and efficiently transmit all of the loads that we want the building to carry. Yes? Mm-hmm. For the, mm-hmm. No, I haven't come across those as yet. I will. Mm-hmm. No surprise, no surprise. But then to answer that question, I am not aware of any investigation that the association may or may not have carried out regarding those plastic ties. As an engineer, I would not recommend that we have plastic ties for our reinforcement. Again, like you said, just in transporting alone, those ties break. So we do generally specify you either use tie and wire or you weld them together. Sometimes I know there are some engineers who prefer the tie because depending on the quality of the weld, that can break. So in the weld, and I don't think we have anybody in St. Lucia who specializes in testing and checking welds before we install anything. I remember I was on a project a couple of years ago, and they actually brought in somebody from Trinidad to check the welds, the quality of the welds, because we don't have anybody in St. Lucia who focuses or specializes in welding and quality and checking and making sure that the weld that we get from the contractors or whoever the contractors hire is exactly. Yeah, because they're basically tacking it onto the, so again, that is why we prefer the tie and wire instead of the weld. Since we cannot exactly check the quality of that weld, we would recommend the tie and wire, or prefer to use the tie and wire.
We have a question. I think Marie-Therese had her hand up. I think she had a question.
Thank you. I wanted to just add some things. I noted that the code was referenced. I read in a paper that on the seismic hazard assessment for the Eastern Caribbean that the Council of Caribbean Engineering Organization and engineers had taken a decision that we would, as the Eastern Caribbean associations, would adopt the suite of codes from the International Code Council. So that means the International Building Code is the one that had been agreed that we would use. I think it would be beneficial to confirm that decision, particularly as I think one of our, the association's president, the Engineers Association may be part of that council, right? So it's actually a decision that was taken, and the code that is recommended for use for us is the International Building Code for new buildings, International Residential Code for homes. With regard to locally, I think the OECS Building Code was last updated in 2016, and it is something that is readily available. The building guidelines may be applicable here. The OECS updated it, I think, in 2018. I'm not sure why it's not publicly available. All of the information, I think, that was presented, which was very great, is available in that document in visual forms. And I think that preparing a handbook that is accessible to persons on site may be something that the Architects Association and Engineers Association should be pushing. With regard to the position of the lab splices, I would like to second or to agree wholeheartedly. I've gone to places where on sites, and you specify the lap splice positions and they are not where they're supposed to be, and you get a lot of pushback. Frankly, when we lap splicing, we're introducing a weakness, as May indicated, and because of our seismicity, which people may not necessarily be aware of, we are considered based on our the seismic the spectral accelerations that we in St. Lucia need to design for. We are considered a high seismic region. So we need to use special detailing. That means that we cannot just lap splice anywhere, particularly in the columns that are going to be used as part of the seismic force resisting system. They're supposed to be the lap splice. You can only lap splice in a column that will be part of the seismic force resisting system at the middle of the column, right? And when you're lap splicing over there, you need to reduce the spacing of your column ties. That's how I know them, right? So, when it is specified on a drawing, it should be adhered to, and the standard practices as indicated in things like the building guidelines are there for a reason, because we have seen things perform, the guidance in these guidelines has been that structures that are detailed or constructed with these guidelines perform better in the hazards that we face. I noted there was a reference to weldable or welding reinforcement. There was some reference to that during the presentation. Not all reinforcement should be welded. The ones that are should be the ones that are the type that is readily available locally is not to be welded. You need weldable reinforcement, which is a different type of reinforcement. The ones that I have seen available on the market is the American steel, the ASTM A615, generally is grade 60. You need the A706, which is weldable. So not all reinforcement should be welded. I think the mills, one of the things that I wanted to add was the mill test certificates. I think if we buy in a product, we should know what we're getting. Every time you buy in steel reinforcement, the suppliers who have purchased it from wherever they have, they get a mill test certificate to confirm the quality of the materials that they are getting. You should get, I would like to push for design professionals to request this, and for persons to have, who are, want to ensure the quality of what they have, should request this from the suppliers. But lastly, for the plastic spacers, I would say that back to submittals, which I mentioned earlier, the submitted products that are available should have product data, so that you can confirm, the integrity and what it is able to do. So I would argue that if you want to use plastic spacers, then get information from the suppliers who should be able to give it to you, for you to confirm the where it can be used. Okay.
All right. Yes. Great point. Now I actually want to go back to something you had said earlier as well, and I think that we need to require more information on drawings that are being submitted for approval, because you have to keep in mind, especially with smaller homes, the vast majority of them are not designed by professionals. The vast majority are designed by technicians and draftsmen, and the vast majority of them don't have any specification documents, and that's usually where you would find things like your concrete strengths, etc. So most people in St. Lucia who obtain approval from DCA for their private residences or smaller buildings don't have any specification of what strength of concrete should be used here and there, and even the spaces. Well, I mean, I suppose on some drawings they might show the spacing required, not the spacing, sorry, the coverage, but not all of them do. And this is a major issue when it comes to construction, because now your contractor does, well, or better yet, the client has nothing to fall back on if a wrong strength of concrete is used, because there's nothing specified for that specific building, And again, comes back to supervision. You want someone supervising who can advise the contractor and say, well, no, even if the drawing didn't say what the coverage is in this area, you need at least 2 inches in this area. So, cut that steel back a bit. So I think that these are some things that between the Engineers Association and the Architects Institute, we should be pushing for at the planning approval level. Okay. That's it right there? Okay, so. Mhm.
This goes against what you learn to avoid. Is that not going to damage reinforcement in the same manner as glass or steel will?
Okay, so I'm not sure if the person's online heard. So it's the first speaker mentioned curing concrete slabs using some kind of salt. This goes against what he learned, and that he believes that the salt would damage the reinforcement. I can get Mr. Linus Gustav to reply to that, but from what I understand, this is not a typical salt. This is something specifically designed to draw moisture. Linus, are you there? Would you like to respond?
Yeah, this is not the regular salt as we know it. Calcium chloride. This is designed specifically for retaining water moisture on the concrete surface. So the question is a legitimate question, but it's not the regular salt to damage the steel. No, this is designed specifically to keep the water moisture present on the concrete.
Yeah. Okay. Thank you.
As I'm here, Miss great presentation, but I want to speak to the lap splicing and sizing for a cantilever veranda. You have, especially in St. Lucia, homeowners love their verandas a little greater than 5 feet. But when you do a steel inspection, you see in a T12 on the cantilevers. Is there anything in the code that speaks to the sizing when it comes to a cantilever veranda greater than 5 feet?
Well, I'll allow me to come and respond, I suppose. But yeah. I mean, as far as I know, the engineer would basically design for whatever cantilever is required. I don't know if you want to respond.
So for cantilever verandas, as Jamal said, the engineer would once it's greater than 6 feet, that's 2 meters, then it would have to be designed for it to be able to withstand all of the loading, because a cantilever behaves completely differently to, say, a beam that has a column on either end of it. So we would have to design it so that, and size the reinforcement and space it so that that cantilever balcony, for example, can properly transmit any load that is on it.
All right, thank you. Okay, Mr. Poyet has a question.
In relation to
okay, you want to come up and, yeah, just so that I don't have to repeat the whole thing.
Hi. Okay, so it's going back to the idea of CB sticks that have been done on the side. So you have cases where, say, somebody has a 10 by 10 column. There's a cage reinforcement for that column of stirrup, which is average, say about, you have 2-inch cover, right? So you have, what, 6 by 6? So when your column reinforcement comes up, the beams normally would go inside that, but there are cases where, see, either the concrete is not cast properly. So what the guys do on site, they put the reinforcement is not in the center of that cage, right? It falls somewhere on the side of it. But there are cases where you still get the adequate cover, right? Just try to think of what's happening inside the beam, right? Because the reinforcement is on the side. I just want you to explain, how does that beam behave if it's done that way? Whether it's something you would approve.
It is something what I personally would not approve of it simply because that beam was not designed to transmit load in that way. So generally, when we have members or elements connected to others, we tend to or preferably prefer that the center of each of those elements or members are connected. So if I have a beam and a column, I would prefer that the center of the beam coincides with the center of the column. So in that way, the loads are transmitted directly through their centers to, well, all the way down, following the chain to the bearing ground. Now, when you put that reinforcement, if it is designed that way, or before I go there, we can also design it such that even if the centers do coincide, but the loading is transmitted rather to the side. That's something that we call eccentric loading. So a column, for example, this might be the center of my column, but then the load that I have coming down, instead of it coming down directly or through the center, being transmitted directly through the center of the column, I can have the load acting somewhere to the side of that center, which means I'm also inducing what we call a moment. So it can also cause the column with that induced moment. Now it also causes that member to kind of rotate or turn. So it might bend about that axis. So it has to be designed for that any load on it to be transmitted in that way. So when we now design it so that everything coincides in the center, and then you as a contractor now come and put the steel to the side of it, is going to behave as though the loading is to the side, whereas it was not designed to behave that way. So then now that can start inducing, with all of that now your stresses are induced inside or within those members, and then you can have cracking starting to form. You have your cover might be falling off or chipping up because it might be cracking right close to the where the cover of the cover to the reinforcement and the reinforcement itself meet, and all of those things, simply because it was not designed to transmit the load in that way. Then it's slightly off. Now,
even now, I'm not seeing a with a lot of I suspect it is something that is caused as a result of
could possibly.
So, moving forward, what do you recommend?
Well, one of the things that we tend to practice where I currently work is that in a case like that, what we would tend to do is make the column slightly wider. So instead of putting, say, a 10 by 10 column, what we might do is say put a 12 by 12 column or probably 14 by 14, so that the reinforcement for the beam can be tied properly to the reinforcement for the column, so that you're not offsetting the reinforcement for either one of them whenever you're preparing it or assembling them or putting them together. So that's one of the things that I can recommend be done. Mm-hmm.
You will not work there. Come in independent to go into the present.
Mm-hmm.
It has all these babies on the floor.
Mm-hmm.
And when you reach up there, struggling to push it in. You're supposed to
Yes,
go up. Secure that. When it happens, come out. But again, it's about Jamal's supervision.
Yeah.
And also time. Like making 25 babies. At my lens, I guess long that time.
But you see, again, like you say, and it goes back to what Jamal said about supervision. And then you now, especially as a foreman or having a foreman on site and having that person go and take the measurements that they need, they would have the drawings so they know what reinforcement they're going to use, the shape of the reinforcement, the size of the reinforcement, where exactly that reinforcement is going to fall, so that they can now form, if you want to do or prepare the cages on the ground, you know exactly how you're going to prepare them, so that when you go and you raise the cage for the beam, for example, to connect it to the column, you should not have an issue. So those cages would have to be properly and adequately prepared on the ground by first having gone through studying your drawings. Yeah, but if, Now where we have the prefab cages, so then when we have those now, you would have to prepare the hook and splice the hook adequately to that cage. Well, you would end up increasing cost, but it would somewhat amount to the same thing. Maybe the cost might be a little more, but structurally and when we're looking at constructability, it would kind of equate to the same thing, because you must provide those hooks at the ends of those members so that they can all connect to each other properly. So then if you go to Bryce, for example, and you buy a cage for the beam, it's coming straight, it doesn't have the hooks on the ends. So it means that you now have to prepare the hook and splice it adequately onto the cage that you are getting from Bryce, so that you can now come and install that cage properly, so that we can have that proper connectivity between the beam and the column. Yeah, so that's why I'm saying that you now would have to make the hook and tie the hook onto that cage, making sure that you have adequate splicing. So if, for example, the main bars in that cage is a 1/2-inch bar, it means that you now have to make a hook such that the length of your hook would be 12 times 12, that's 144. We cannot put anything shorter than that, so we go up to the nearest 25, that's 150, so that's 6 inches. And then the length now coming this way, which would tie to the cage that you have now bought from Bryce, would be 40 times the diameter of the bar, which is 40 times 12, that's 480. So say 600 in length. That's 600 millimeters. You would now tie to that cage that you get from Bryce, and then add the additional stirrups that you would need to it before you install that cage. It's going to cost you, it might cost you a little more, but at least you know that safety is more important. And nobody's coming back banging on your door where you owe me a house, or you owe me this, or you have $100,000 for me because my house failed, my house collapsed on top of me. So, yeah. Well, that's why I say we are kind of lucky still. But I'm sure there are instances where persons may have taken somebody to task for those.
All right. I don't notice any other questions, but I think we need to move on to our next presentation so we can sort of stay on schedule. I think we've sort of made up our time, but we're now running a little past again. To close on that, I think I would say that that's a very valid point that was brought up by Mr. Poet and continued in that discussion. But I think the takeaway is that if you're ordering pre-made cages, keep in mind that they don't come with the hooks to go in. So it's not that you're adding on cost. What you may have saved on ordering your pre-made, you just put in a little bit back to make your hooks. All right. So I will ask Mr. Poyot. We're going to move on to Mr. Poyot's presentation now on walls.